A wheel having moment of inertia. So moment of inertia is given. How much? I equal to 2 kg meter square. About its vertical axis, rotate at the rate of 60 revolution per minute. Here we have to understand clearly revolution per minute they given. About this axis, the torque which can stop, the torque which can stop the wheel's rotation in 1 minute would be. So here angular speed, final angular speed must be 0. Why? It must be stopped. So that's why final angular speed is 0. In 1 minute, in 1 minute in the sense 60 seconds. 60 seconds. So we know the formula, final angular speed equal to initial angular speed minus angular retardation into time. From this, anyway this will become 0, angular initial speed minus alpha into t2, then we will get alpha equal to omega I by t. Now, so torque, so we have to find out the torque, I into alpha, I into alpha, I into omega in, that is by angular speed by time. So this is alpha only, right? This is only right, alpha. So instead of this one we substituted here. Okay, now I into, so 2 pi v by t, 2 pi. So now I we know what is I, 2. I value is 2. So substitute the value 2 into 2 into pi into angular speed is how much? 60 revolution per minute. So 60 rpm. 60 rpm means 60 by 60 we can say. So 60 by. So time is already there. 60 by 60 into time 60. Because 1 minute they given, no? 1 minute is nothing but 60 seconds. So 60 seconds. If you do this, so torque is produced. So that is torque is required which can stop the wheel's rotation. That is 5 by 15 Newton meter. So this is the answer. So we'll check the answer, 5 by 15. So here only, right? 5 by 15 is here. So option C. This is the answer. So if you like this content, do like, share and subscribe to Student the Brand. Thank you.